Hello. The purpose of this video is to talk to you about ions. An ion is a charged atom, and there are two varieties of charged atoms. And the way an atom becomes charged is that it either gains or loses electrons. So it never gains or loses protons. The protons always remain the same. The electrons that it would gain or lose would come from the valence electrons. And as you recall, from the periodic table, we can predict the number of valence electrons that an element has based upon which column of the periodic table it's in. For example, the first column in the periodic table has one valence electron. The second column of the periodic table has two valence electrons. We skip the transition metals, jump over here. The third column of the periodic table has three, and then so on and so forth until we get all the way over to this side where the last column in the periodic table has 8 valence electrons, and that's the noble gases. So we can represent the number of valence electrons that an atom has with a Lewis dot structure. Okay, a Lewis dot structure for sodium, okay, would just be one dot because it has one valence electron. It's right here in the periodic table. On the other hand, a Lewis dot structure for chlorine would have 7 dots. And it doesn't really matter where you put the dots as long as you have the right number. So as long as you have 7 dots around here, you're good. Atoms gain or lose electrons so that they look like noble gases. They're trying to gain stability, and what we know about noble gases, which is the last column in the periodic table, is that they're stable. So the rest of these elements are trying to look like the noble gases. So the way you predict whether or not an atom will gain electrons to do that or lose electrons is just simplicity. So for example, sodium, which has one valence electron, happens to be right here in the periodic table. Now, in order for it to look like a noble gas, it would either have to gain 7 electrons to look like argon, or if it loses 1, it looks like neon. So if we do the Lewis dot structure for sodium, which would be 1s2, 2s2, 2p6, 3s1. Okay, as you can see, it has 1 valence electron in the 3rd energy level. Okay, so it is going to lose that electron, and now it looks like neon, because neon is element 10, and it has an electron configuration of that. When sodium does that, now all of a sudden it has a +1 charge because it has 1 less electron than protons. So right now it would have 11 protons and only 10 electrons. So we would represent the symbol for sodium as Na+1. We would then call that atom a sodium cation. And as you recall from our previous chapter, cations are positive and anions are negative. So let's take a look at an example of an anion. Chlorine becomes an anion. So chlorine which has 7 electrons and 7 protons in a neutral atom, would have an electron configuration that looks like that. 1s2, 2s2, 2p6, 3s2, 3p5. And so chlorine is right there in the periodic table. Now, so it can do one of two things to look like a noble gas. Either it can lose 7 electrons and look like neon, which would be a lot harder to do than it would be to gain 1 electron and look like argon. So argon is element 18. And so if chlorine added 1 more electron, it would look like argon. So when it gains an electron, it has a -1 charge then. And so we would call this a chloride anion. Notice that I changed the ending from chlorine to chloride. When you're naming anions, you always do that. So a chloride anion would be like this. So if you had a fluorine anion, it would be fluoride. If you had a hydrogen anion, it would be hydride. If you had an oxygen anion, it would be oxide. So always add IDE to the end of the name. So that's all I have for today.